This lesson is on calculating slope. We're learning that slope is a measure of steepness. So the larger the slope, the steeper the line or slope will be. We're learning to use the formula slope equals rise over run. Notice that M stands for slope in this case. They don't use S because it can be mistaken for a 5, so M. And the formula is the slope M is equal to the rise divided by the run. Slope is the measure of the steepness of a line. Slope, also referred to as the rate of change, is the ratio of the rise or the vertical change to the run or the horizontal change. Remember, horizontal is this way, and vertical is up and down. And then we have our slope formula. Slope equals rise over run. Really important formula. So here we have determined the slope of the roof. So the slope of our roof, we'll use our formula slope equals rise over run. And we're shown that the rise is 3 meters. And the run is 5 meters. And you're just left with the slope being 3 over 5. Or if we wanted to change that to a decimal, you could do 3 divided by 5, which is another way to write 3/5 as a decimal is 0.6. Okay, so that's a measure of the steepness of this roof line here. Okay, so there's the slope of the roof. Determine the slope of each ski hill. Rate them from the gentlest slope, so the easiest one to ski down, and the steepest slope, which would be the hardest one to ski down. So we're going to have to find each one. So we'll find A first, and we can see here that our rise is 60 meters, and our run is 70 meters. Remember again, rise is up and down, run is horizontal. So our slope is the rise divided by the run, or 60 over 70, which is, if you divide by 10, 6 over 7, or approximately, if you divide 6 by 7, you can get it as a decimal. Approximately, it's a decimal you can see that goes on and doesn't appear to repeat. Oh, it does repeat, sorry, eventually, but we could say approximately 0.9. If we round to one decimal place, the 5 rounds the 8 up. Okay, and then we're going to compare it to our next one. It looks less steep. Let's see if it is. So we've got our run is 110 meters and our rise is 60 meters. So the slope is the rise divided by the run, which is 60 over 110, which reduces to, if you divide top and bottom by 10, 6 over 11, which we know is going to be smaller, but we can figure it out as a decimal too. 6 divided by 11 is approximately 0.5, so definitely less steep. And then for C, we've got our rise to be 80 meters and our run to be 100. So our slope is going to be the rise 80 meters over the run 100 meters, which works out to 8/10 or 0.8. So that would mean that the gentlest slope, the easiest one to ski down, is this one, B. gentlest. And the steepest is the biggest number, which is approximately 0.9, and that's going to be the steepest. So you've got A being the steepest with the biggest number representing the slope, and B being the gentlest with the smallest number representing the slope. Okay, so some important things to know about slope is if you imagine a little ant here, I can't really draw one, but he's crawling uphill. That's considered a positive slope. And that's it as you're moving from left to right. So as you're moving from left to right, he's going uphill where the line is increasing. That's considered to be a positive slope. If the little ant is crawling down the hill as we move left to right, or decreasing as we move left to right, we are considered to have a negative slope. And if you look up here, I did examples originally where all of our slopes were positive. So even though the skier's skiing downhill, you can see that if we go from left to right, our slope is rising. And same with our roof line up here. So I made them all positive before we discussed that slope can be negative as well. Okay, so as you move from left to right, if you're decreasing, then you have a negative slope. Just horizontal, it makes sense that the slope would be 0 because the rise is 0, if you want to say that, the rise is 0, or it's flat. It makes sense that it has no slope because it's flat. And this is the steepest slope you could ever have. It's like an infinite slope, like falling off a cliff. So our poor little ant just comes here and then falls off the edge. Here it's just walking across straight, no slope at all, doesn't take very much effort. Slope is 0, but here we just fall off the cliff and we have an infinite slope, which is considered to be undefined. Okay, so slope, you can have a positive slope if you're going uphill from left to right, negative slope if you're going downhill or decreasing from left to right, a slope of 0 if it's flat, and a slope that's undefined if it's vertical. So we're going to determine the slope of each line segment using our formula. So if I look here, this one's kind of marked on the run and the rise for me. So I just have to count and look, make sure I take into consideration the scale of my graph here. So it's by ones. So the run is 1, 2, and the rise is, this is by ones again, so 1, 2, 3. So the slope is the rise over the run. Oh, and it's positive slope because as we go from left to right, it's rising. So we know it's going to be a positive slope. And the rise is 3 and the run is 2. So the slope is 3 over 2. And that's an improper fraction in lowest terms. That's normally how we like to leave slope. You can change it to a decimal, but I wouldn't unless it works out to a whole number or it's in a part of a word problem. So our next one, we're going to label the rise and the run here. So I'm going to go over and up. So and then I'm going to also look at the scale of my graph here. So horizontally, each one square is going to represent 4 because 2 squares represents 8. So if I'm counting out my run, it's going to be 4, 8, 12, 16, 20, 24, 28. So our run is 28. But for our rise, the scale is by 2s, so each square represents 2. So for my rise, I've got 2, 4, 6, 8, 10, 12. So my rise is 12. So remember, it's really important that you look at the scale of the graph or you won't get the correct answer if you always just count by ones. All right, so we've got slope is the rise divided by the run. In our case, that's 12 divided by 28, which reduces, they're both divisible by 4. So that gives us 3/7 is the slope of that line segment. So again, make sure you look at the scales of the graph. Oh, and again, this one was positive, and our slope is positive. Next one, this one's a negative slope. We can see that as we go from left to right, we're decreasing, so this is going to have a negative slope. And I'm going to mark on my rise, which we're going to talk about being a negative rise. And we always run to the right. So first let's do our run. So we can see that each square here represents 1. So 1, 2, 3, 4, 5, 6, 7, 8. Our run is 8. Whereas on our vertical axis, each square represents 5, because 2 represent 10. And we're going to think of it, because we're decreasing, it's going to be a negative rise. So our rise is going to end up being negative. 5, 10, 15, 20, 25, 30. So our rise is negative 30 because we're going downward, decreasing slope. So here's our, we would be going downward as we go from left to right. So our slope is still going to be the rise over the run. In our case, our rise is negative, so we're going to keep that negative sign with our rise, negative 30 over 8, which reduces by 2's to negative 15 over 4. And there's my improper fraction in lowest terms. Okay, moving on to another example. Sketch the line from the table of values and determine its slope. All right, so we've learned how to sketch ordered pairs. So this x is 1 and y is 10. Let's see if what our scale is going to be first. So we see that our x values have to go from 1 to 4, but our y values have to go from 10 all the way up to 40. So we're not going to go by ones. Probably on either scale, I'm going to make every 2 squares 1 horizontally. And vertically, I'm going to make every 2 squares 10. So I can fit all my points on my graph here. Remember, this is the first column always represents your horizontal, and the second column is always your vertical. X is horizontal, Y is vertical. So when X is 1, Y is 10 corresponds to the point right 1 up to 10, which is right there. The second entry here, 220, means when X is 2, Y is 20, so that's going to be that point right there. When X is 3, Y is 30, so this point right here. And when X is 4, Y is 40, so this point right here. So we can draw that graph using our ruler. And from the graph, we can find the rise and the run and find the slope. So we are going to do that, and we're going to compare it to, I'm going to show you a way to find the slope directly from the table as well, because you won't always have a graph. So here, according to our scale, each square is 0.5 here, so every 2 squares is 1. So I think like 1, 2, 3. So my run is 3. And my rise, every square is 5. So my rise is going to be 5, 10, 15, 20, 25, 30. And it's positive sloping because it rises to the right. So according to my graph, the slope is the rise over the run, or 30 over 3, which is 10. So I'm going to show you how to get that same answer just working with the table of values. So what we look at is called differences, or the changes in y. So as we go from the first point to the second point, the y value increases by 10. 20 to 30 is another increase by 10. 30 to 40 is another increase by 10. So these are my rises, because this is what's happening vertically. Okay, so my rises are up by 10. And my run, I'm going from 1 to 2, then 2 to 3, and then 3 to 4. So these are the changes in my x value, or the run. Okay? So rise, sometimes you'll see it called change in, or you'll hear it called change in y, or delta y. Delta means change in. And sometimes you'll see run called change in x. That change in is really important. It's not just the x value, it's the change in the x value. It's not just the y value, it's the change in the y value. So change in x, or delta x, is another name for run. But we're going to stick in this course with rise and run for the most part. So our vertical changes are the rise, our horizontal are the run, and then we can just use our formula. And you can see that in this case, every time we go up 10 vertically, we go up 1 horizontally. They always end up being the same. So our rise is always 10 whenever our run is 1, and 10 divided by 1 is just 10. So we got the same answer using 2 different methods, one just from the table, finding the rise and the run, and one drawing the graph, and also using the same formula and finding the rise and the run. So now we're going to try some examples where we don't have a graph, we just have a table. So we're going to use the table method to find the slope. So first we do our differences. So our differences here are going to end up being our rise, changes in our y value. So 7 up to 11 is up 4, 11 to 15 is up 4, 15 to 19 is up 4. 0 to 1 is up 1, 1 to 2 is up 1, 2 to 3 is up 1. And these are our runs, or change in x. Horizontal change, vertical change. So our slope is going to be the rise over the run. And we can see again they're consistent. Every time we rise 4, we run 1. Every time we rise 4, we run 1. Every time we rise 4, we run 1. So our slope is going to be 4 over 1, or 4 divided by 1, which is just 4. Different analysis here. So to get from 50 to 38, we actually are going down. So if I'm not sure, I would do 38 subtract 50. So to find the rise, you always do the lower one, subtract the upper one, and this time we get negative 12. 26 subtract 38, negative 12 again. We're getting smaller. So this line, if we graphed it, would have a negative slope. 14 subtract 26 is negative 12 again. And then that's our rise, it's negative, so we're going to have a negative slope. And for our run, 0 to 2 is up 2, 2 to 4 is up 2, and 4 to 6 is up 2. So we can see that consistent. Every time we rise negative 12, we run 2. Every time we rise negative 12, our run is 2. And then we can find our slope using the formula. Slope is rise over run. And negative 12 divided by 2 turns out to be negative 6. If I was going to ask you which between these two is steeper, so it doesn't matter that it's negative, a slope of negative 6 is still going to be bigger than a slope of 4. So if we were comparing them, this one's steeper than this one. Okay? So the negative just affects whether it's decreasing. This one's decreasing pretty steeply, and this one's increasing, but not as steep. Okay, so the negative sign affects whether it's increasing or decreasing, not how steep the slope is. So use the slope formula to find the slope of the line that goes through those points 1, -3, and 4, 1. So I'll show you, I think I'll show you 2 ways to do this as well. So first of all, we can plot those points. So make sure they're going to fit on if we go by ones here, which it looks like they will. And remember, this is an X and this is a Y. So to the right 1, down 3 is our first point. And then 4, 1, 1, 2, 3, 4, 1. So that's our line. Is going to go through those 2 points. So you could draw it in. To find the slope of it, we would do our rise and our run between the points. We know it's by ones and we have a positive slope. So our run is 1, 2, 3, and our rise is 4. So from the graph, we can see the slope is the rise over the run, which is 4 over 3, which doesn't reduce nicely, so that's in lowest terms, and we will keep it like that. So that's graphing and drawing in we call it a rate triangle, finding the rise and the run, and using the formula. So another way we could do it, and if we're not given a graph, is to put these points into a table. So we've got our X and our Y. So the first point I put in, I'm gonna just put it in, not right at the top, because I don't know if the next point is gonna go below or above. So my first X value is 1. My second X value here is 4, which is bigger than 1, so I'm gonna put it below. If this X value had been like -2, I would have put it above here. So there's my 2 points, 1, -3 put into my table, and 4, 1 put into my table. Now I can find my rise, or my change in Y. So to go from -3 up to 1 would be up 4. And to go from 1 up to 4 would be up 3. That's going to be my run. So again, I have my rise and my run. I can use the slope formula. And again, I get 4 over 3. Same result. So here's an example where we would want to use the table. Determine the slope of the line segment between the following pair of points. So we're going to set up our table, X and Y. Put our first point in, 90, 170. 40 is smaller than 90, so I'm going to put it above 40 and 470. And then I'm going to find the rise. Now in this case, it's going to be a negative rise. So I want 170 subtract 470. So to get from 471 to 170, I go down 300. So my rise is negative 300. And to get from 40 to 90, I go up 50. So my run is 50. So my slope is going to be the rise divided by the run, which is negative 300 divided by 50, which is negative 6. So the slope is negative 6. Okay, so summary then, 2 ways to calculate slope. So you can use a rate triangle where you find your run and your rise, and use the formula slope is rise over run. And just keep in mind that this is a positive slope And then this would be a negative slope. Oops. Negative slope. So always ask yourself whether you're going to have a positive or negative slope. Whereas if you do it with the table, it'll be more apparent whether your slope's positive or negative. You won't have to check yourself first and make sure, is it rising to the right or falling to the right? So our second way is table. And that's where you put any 2 points in your table. We'll just do like -2 and 6 and 0 and 10. And you find your difference on each side. On the change in y is your rise. The change in x is your run. And then you just use the same formula, but you've calculated your rise as being the change in the y values. And same with your run, change in the x values. And you calculate your slope that way. Okay, so those are the two ways.